Can a tunnel through space-time exist? Tonight, we're going to explore one of the most mind-bending concepts in physics, wormholes. You've probably seen them in countless science fiction movies, from Interstellar to Star Trek. But here's what most people don't realize. Even if a single wormhole could somehow exist for just one moment, it would completely shatter the fundamental laws that govern our entire universe. By the end of this journey, you're going to understand exactly why these cosmic shortcuts aren't just impractical. They're physically impossible in ways that challenge our deepest understanding of reality itself. Before we dive in, if you enjoy these kinds of explorations, a quick like or subscribe really helps the channel grow. It's a small thing for you, but it makes a real difference for me. Get comfortable. Let's begin. Think about that for a second. One tiny tunnel through space-time, and everything we know about reality would collapse. This isn't about the engineering challenges of building such a thing, or the exotic matter it might require. This is about something far more profound. A single functional wormhole would be enough to destroy completely the consistency of all modern physics. That verdict doesn't arise from mathematical complexity, but from fundamental logical contradictions that emerge inevitably. And to understand why that's true, we need to step back and appreciate something we usually take completely for granted. Before we dive into the catastrophe, we need to appreciate what works perfectly without wormholes in our reality. Right now, as you're listening to this, you're surrounded by an almost miraculous stability that makes everything in your life possible. Every piece of technology you use, from the light bulb in your room to the satellites orbiting overhead, depends on three principles that are absolutely stable and reliable. Picture yourself striking a match. The flame appears after the friction, never before. That sequence has never failed, not once, in all of human history. This is our first principle, causality, where causes always precede effects in a manner that's both predictable and invariable. When you flip a light switch, the bulb illuminates after you complete the action, not before you even think about it. When you press the accelerator in your car, the engine responds afterward, following your input with mathematical precision. Your phone battery right now contains a specific amount of energy. As you use it, that energy decreases according to exactly how much power your screen and processor consume. It never increases spontaneously. It never gains energy from nothing. This is our second principle, conservation of energy, guaranteeing that energy total remains constant in closed systems. That battery was charged from electricity that came from a power plant, which got its energy from burning fuel or harnessing wind or capturing sunlight. The energy flows from one form to another, but the total amount never changes. And right now, somewhere in the world, mission controllers are tracking spacecraft that were launched years ago, knowing exactly where those probes will be months into the future. This is our third principle, predictability, allowing us to calculate planetary trajectories with decades of advance notice. We launch spacecraft to Mars knowing precisely where that planet will be 8 months later because physics follows determined rules. These three laws form the foundation upon which we build all scientific understanding of the observable universe. Engineers design bridges that don't collapse because materials behave consistently according to known laws of physics. The steel beams support exactly the weight they're calculated to support. The concrete cures to precisely the strength predicted by chemical equations that have been tested millions of times. Doctors administer precise doses of medications because chemical reactions follow patterns that are reproducible and predictable. Always. When a physician prescribes exactly 200 milligrams of a drug, they know with absolute certainty how those molecules will interact with your biochemistry. The medicine doesn't randomly become more or less potent. The chemical bonds don't suddenly decide to behave differently than they did yesterday. Airline pilots trust that jet engines will function tomorrow exactly as they functioned yesterday under the same operational conditions. Those engines operate according to principles of thermodynamics that have remained constant since the first combustion engine was built. The fuel burns at the same rate, produces the same energy, creates the same thrust. Every flight depends on this unwavering reliability. This stability seems so obvious that we rarely pause to appreciate how extraordinarily dependable our reality truly is. But think about this for a moment. Since the Big Bang, 13,800,000,000 years ago, these laws have never failed a single time, not once. Through the formation of the first stars, the birth of galaxies, the coalescence of our solar system, the emergence of life on Earth, and the entire span of human civilization, the same rules have governed every interaction between every particle. Electrons orbit atomic nuclei the same way today as they orbited when the first stars formed 13 billion years ago. The electron in the oxygen atom you just breathed follows identical quantum mechanical laws as electrons in stars that died before Earth was even born. The fundamental forces haven't grown weaker or stronger. The speed of light hasn't fluctuated. The charge of a proton remains precisely what it was when the universe was only seconds old. Photons travel at the constant velocity of 300 million meters per second in vacuum, never varying that rate. This constancy allows light from galaxies 13 billion light-years distant to reach us, preserving information about the early universe. When you look at starlight tonight, you're seeing photons that began their journey before Earth existed, and they've maintained their properties unchanged across cosmic distances that dwarf human comprehension. Einstein's relativity predicts with incredible precision how GPS systems correct time due to Earth's gravity and orbital velocity. Those corrections are extraordinarily subtle. Relativistic adjustments in GPS satellites amount to adjusting clocks by 38 microseconds per day to maintain accuracy. Without those corrections, GPS would accumulate an error of 11 kilometers per day, making modern navigation completely impossible. That precision demonstrates that we understand physics with extraordinary detail, testing theories to the 10th decimal place constantly. Consider what that means. We can predict the behavior of objects moving at significant fractions of light speed, in gravitational fields millions of times weaker than what we experience on Earth's surface, with accuracy measured in billionths of a second. The Large Hadron Collider confirms theoretical predictions with probability greater than 5 sigma. That's 99.9994% certainty. When physicists at CERN announced the discovery of the Higgs boson in 2012, they were validating predictions made in the 1960s about the fundamental structure of matter. 5 decades of theoretical work confirmed by experiments involving billions of particle collisions, all behaving exactly as the mathematics predicted. Gravitational waves detected in 2015 by LIGO confirmed predictions Einstein made exactly 100 years earlier in 1915. Think about that timeline. Einstein's equations, written on paper in 1915, predicted that accelerating massive objects would create ripples in spacetime itself. A century later, instruments sensitive enough to detect distortions smaller than 1/10,000th the width of a proton confirmed those ripples existed with precisely the characteristics Einstein's mathematics had foretold. This convergence between theory and experiment across an entire century attests to the unshakable solidity of established modern physics. But here's what's crucial to understand. That solidity depends critically on space and time, maintaining a specific structure that prevents certain types of connections. The fabric of spacetime possesses a geometry that forces events to follow rigorous causal order without any possible exceptions. Picture spacetime as a vast tapestry where every thread connects to its neighbors in a precise pattern. That pattern ensures that information can only flow in one direction through time, that energy can only move according to conservation laws, that effects always follow causes in an orderly sequence. It is precisely this protective structure that a wormhole would violate catastrophically. And as we'll see, even the mere possibility of such a violation doesn't just bend the rules of physics, it breaks them so completely that the entire framework of scientific understanding collapses into logical contradiction. What seems like a simple geometric shortcut through space turns out to be a doorway to impossible paradoxes that would render the universe itself inconsistent and incomprehensible. But let's step back for a moment and consider why wormholes seem so appealing in the first place. A wormhole appears initially to be just a geometric shortcut through space, connecting two distant points instantaneously. Picture it like a tunnel bored through a mountain that shortens a journey from 100 kilometers to just 2 kilometers direct. It's an elegant solution to the tyranny of distance that governs our universe. The concept seems so straightforward that you might wonder why anyone would object to it. After all, we create shortcuts through space all the time. When you take a highway that cuts straight across a valley instead of following the winding river below, you're creating a spatial shortcut. When engineers build a bridge spanning a canyon, they're allowing people to bypass the longer route around the rim. What could be more natural than extending this principle to cosmic scales? Einstein's equations in general relativity technically do permit these bridges in spacetime under specific mathematical conditions. This isn't science fiction wishful thinking. The mathematics is rigorous and well established. The equations that govern gravity, the same equations that predict black holes and the expansion of the universe, also allow for these exotic geometries. As early as 1916, just 1 year after Einstein published his theory of general relativity, Carl Schwarzschild found solutions to Einstein's field equations that described what we now call Einstein-Rosen bridges. Schwarzschild was actually solving these equations while serving as a soldier on the Russian front during World War I. He died of typhus shortly after making this mathematical discovery, never knowing he had described a potential pathway through space-time itself. These bridges would theoretically connect two mouths of a wormhole, separated by millions of kilometers through a tunnel only meters long. Imagine folding a piece of paper in half and piercing it with a pen. The pen tip can travel from one side to the other without traversing all the surface area between those points. The wormhole represents a similar geometric trick, but played out in the four-dimensional fabric of space-time itself. The analogy is compelling, but it's also deceptive. When you fold paper, you're using a third dimension, depth, to connect 2 points on the two-dimensional surface. Similarly, a wormhole would use higher dimensions to connect distant regions of our familiar three-dimensional space. The mathematics suggests this is possible, even if we can't visualize higher dimensions directly. Mathematically, wormholes satisfy Einstein's field equations that govern how mass and energy curve the geometry of space-time. These are the same equations that tell us how planets orbit stars, how light bends around massive objects, and how time dilates in gravitational fields. The equations don't prohibit wormholes. They simply require very specific exotic conditions to exist. In 1988, physicist Kip Thorne and his colleagues at Caltech demonstrated mathematically the possibility of traversable wormholes that wouldn't collapse immediately upon formation. This was serious theoretical work, published in peer-reviewed journals, exploring what would be needed to make science fiction's favorite plot device actually work in our universe. But here's where things get exotic. To maintain a wormhole in an open state would require what physicists call exotic matter with negative energy density, something that contradicts all known forms of matter and energy. Negative energy density means having less energy than absolute vacuum, something that seems to violate our basic physical intuition fundamentally. Think about what that means for a moment. Empty space. The vacuum between stars isn't actually empty. It's filled with quantum fluctuations, virtual particles popping in and out of existence in patterns that fill every cubic centimeter of seemingly empty space. This quantum vacuum has a certain baseline energy density, like a constant background hum of activity. Exotic matter would need to have less energy than that quantum vacuum, less energy than what we consider to be nothing. It would be like having a debt of energy, a negative amount that somehow exists in physical reality. Every form of matter and energy we've ever encountered adds to the total energy budget of the universe. Exotic matter would subtract from it. Yet remarkably, the Casimir effect, demonstrated experimentally in 1948 by Dutch physicist Hendrik Casimir, shows that quantum vacuum can indeed exhibit negative energy on microscopic scales. Between two perfectly conducting metallic plates separated by nanometers, the quantum vacuum exerts measurable negative pressure. Billionths of a Newton, but definitely negative. The plates are literally pushed together by negative energy density. This happens because the metal plates restrict which quantum fluctuations can exist between them. Only fluctuations with wavelengths that fit exactly between the plates are allowed. Since longer wavelengths are excluded from the interior space, there's actually less vacuum energy between the plates than in the surrounding empty space. The result is a region with negative energy density relative to normal vacuum. This suggests that perhaps the exotic matter required for wormholes doesn't completely violate known laws of physics, but simply extends them radically beyond our current understanding. If we could somehow amplify the Casimir effect to macroscopic scales, we might be able to create the negative energy densities required. But the engineering challenges would be staggering. A traversable wormhole would require negative mass equivalent to approximately the mass of Jupiter concentrated within the tunnel structure. Jupiter contains 1.9 × 10⁻27 kilograms. That's 1,900 trillion kilograms. To put this in perspective, if you could somehow convert the entire mass of Earth into negative energy, you'd still need about 318 more Earths worth of exotic matter to stabilize a single wormhole. But let's assume, for the sake of argument, that some impossibly advanced civilization could create and stabilize such a structure. Perhaps they've mastered technologies we can't even imagine, found ways to manufacture negative energy in vast quantities, and to solve the engineering problems that seem impossible to us today. Initially, the wormhole would seem to function perfectly as a spatial shortcut, allowing instantaneous travel between its two separated mouths. Picture an astronaut entering Mouth A, located on Earth, and emerging instantaneously at Mouth B near Proxima Centauri, the closest star to our Sun. From the outside, the process would look like the ultimate transportation system. Step into one end, step out of the other, covering interstellar distances in the time it takes to walk across a room. Proxima Centauri sits 4.2 light-years away from Earth. To reach it with current rocket technology would require about 40,000 years of travel. Even with theoretical fusion rockets or solar sails that could achieve a significant fraction of light speed, the journey would still take decades. Through the wormhole, that epic voyage would be reduced to seconds, crossing a tunnel only a few meters in internal length. From the traveler's perspective, the passage would be smooth and instantaneous, without extreme tidal forces or apparent side effects. Unlike the deadly environment near a black hole's event horizon, where tidal forces would stretch you into a strand of atoms, a properly constructed wormhole would provide gentle passage. You might not even realize you had traveled interstellar distances until you emerged and looked up at an alien sky. Observers at both mouths would see the astronaut disappear at point A and appear at point B with no measurable time interval between the events. To them, it would seem like teleportation. Matter vanishing from one location and simultaneously materializing at another, separated by distances that light normally requires years to cross. Up to this point, the wormhole seems like a mere innocent geometric shortcut that doesn't violate any fundamental physical laws. Engineers might begin planning an interstellar transport network, connecting thousands of star systems instantaneously. Imagine the possibilities. Colonies scattered across the galaxy but connected as if they were neighboring cities. Scientific expeditions to distant worlds that could return home for lunch. Trade networks spanning light years that operate in real time. An advanced civilization could build galactic infrastructure with wormholes linking colonies separated by tens of thousands of light years. The Andromeda galaxy, currently 5 million light years away and unreachable by any conventional means, could become as accessible as the next county. The entire observable universe could become humanity's backyard, connected by a web of spatial shortcuts that make distance irrelevant. This optimistic vision assumes that space and time are separate, independent entities that can be manipulated in isolation. You create a spatial shortcut without affecting temporal relationships. You fold space while leaving time completely untouched. Distance becomes meaningless, while causality remains intact. But here lies the fundamental error that leads to physics' complete collapse. The assumption is as natural as it is wrong. In our everyday experience, space and time do seem separate. You can rearrange furniture in your room without affecting the clock on your wall. You can travel to different locations without time flowing differently. The independence of space and time feels obvious because the effects of their unification only become noticeable at very high speeds or in very strong gravitational fields. But space and time are inseparably woven into a unified fabric. Einstein demonstrated in 1905 that space and time form a single four-dimensional continuum where both are intrinsically intertwined always. This wasn't just a mathematical convenience or an abstract theoretical concept. It was a profound insight into reality's fundamental structure. Think about this carefully. Any distortion in space necessarily causes a corresponding distortion in time due to the intrinsic geometry of unified spacetime. You cannot create a purely spatial shortcut any more than you can have the width of a rectangle without affecting its area when you change the height. The dimensions are locked together by the mathematical structure of reality itself. When you look at your GPS right now, you're seeing proof of this unity every time it shows your location. Those satellites orbit about 20,000 kilometers above Earth's surface, where gravity is slightly weaker than what you experience at ground level. That weaker gravity doesn't just affect the spatial curvature around the satellites, it causes time itself to flow about 45 microseconds faster per day compared to clocks on Earth's surface. Simultaneously, the satellites travel at approximately 14,000 kilometers per hour relative to Earth's surface. That motion through space doesn't just change their position, it causes their onboard clocks to run about 7 microseconds slower per day due to velocity-induced time dilation. These aren't separate effects that happen to occur together by coincidence. They're different manifestations of the same underlying geometric reality. Without accounting for both effects, the gravitational time dilation and the velocity-induced time dilation, GPS would accumulate position errors of about 11 kilometers per day. The system works precisely because engineers understand that manipulating space automatically manipulates time. Move a satellite to a different orbital altitude, and you've changed how fast time flows at that location. Therefore, when you create a spatial shortcut, a wormhole inevitably creates a temporal shortcut as well, with devastating consequences. This isn't a side effect or an additional complication that clever engineering might avoid. It's a direct, unavoidable consequence of spacetime's unified structure. Consider what this means for our hypothetical wormhole connecting Earth to Proxima Centauri. Light traveling through normal space takes 4.2 years to make that journey. That's not just a statement about distance. It's a statement about the fundamental relationship between space and time, built into the geometry of spacetime itself. By creating an instantaneous spatial connection, the wormhole allows you to arrive at Proxima Centauri essentially before light could have made the conventional journey. From the perspective of spacetime geometry, you've effectively traveled into the future relative to the normal light speed path. But Einstein's relativity teaches us that what constitutes simultaneous events depends entirely on your reference frame and motion. Here's where the trap begins to close around the foundations of physics. The wormhole that seemed like a simple spatial convenience has just become a time machine. And once you have a time machine, even inadvertently, even if you never intended to build one, the logical foundations of physics begin to crumble in ways that are as inevitable as they are catastrophic. Therefore, by creating a spatial shortcut, a wormhole inevitably creates a temporal shortcut as well, with devastating consequences that we'll now explore. To understand why this temporal connection is so catastrophic, we need to delve deeper into one of the most profound revelations in all of physics. Special relativity revealed that space and time are not separate stages upon which events unfold, but components of a single, unified four-dimensional reality. Think of it like the height and width of a rectangle. You cannot alter one dimension independently without changing the total area of the shape. This unity isn't just a mathematical convenience or an abstract concept that physicists invented to make their equations work. It's a fundamental aspect of reality that was forced upon us by experimental evidence. The famous Michelson-Morley experiment in 1887 demonstrated that the speed of light remains constant at exactly 209,792 kilometers per second in vacuum, regardless of the motion of the observer measuring it. This constancy seemed bizarre, almost impossible. When you're driving toward an oncoming car, the relative speed is the sum of both vehicles' speeds. When you're chasing a car traveling in the same direction, the relative speed is the difference. But light doesn't behave this way. Whether you're moving toward a light source or away from it, racing toward it at tremendous speed or sitting perfectly still, you always measure exactly the same velocity for those photons. This bizarre constancy only makes sense if time passes differently for observers in relative motion to each other. Einstein realized that what we perceive as simultaneous events depends entirely on our motion through space-time. Time itself becomes elastic, stretching and compressing based on velocity and gravity in ways that preserve the speed of light as an absolute constant. Consider an astronaut traveling at 86.6% of light speed. Due to time dilation, this traveler experiences time passing at exactly half the rate compared to someone remaining on Earth. If the astronaut journeys for 10 years according to their own clock, 20 full years will have passed on Earth when they return. This isn't science fiction, it's measured, verified physics. The time dilation isn't an illusion or measurement error, but a real difference in biological aging that's completely measurable and verifiable. The traveling twin literally ages more slowly. Their cellular processes, radioactive decay rates, even the vibrations of atoms in their body, all occur at half the normal rate relative to Earth's reference frame. They return younger than their Earth-bound twin in every measurable sense. We see this effect constantly in cosmic ray showers hitting Earth's atmosphere. Muons created in the upper atmosphere at about 15 kilometers, altitude should decay before reaching the surface, according to classical physics. These unstable particles have a half-life of just 2.2 microseconds, which should allow them to travel only about 660 meters before disintegrating. However, moons travel at 99.9% of light speed, causing time dilation by a factor of 22. From our perspective on Earth's surface, the muons live 22 times longer than they should, giving them enough time to reach our detectors. From the muon's perspective, time dilation makes Earth's atmosphere appear compressed to only 700 meters thick instead of the full 15 kilometers. Either way you calculate it, millions of muons reach detectors at Earth's surface daily, providing continuous experimental confirmation that time really does dilate with velocity. GPS satellites demonstrate the opposite effect. These spacecraft orbit at about 20,000 kilometers altitude, where Earth's gravity is weaker than at the surface. According to Einstein's general relativity, weaker gravity causes time to flow more rapidly. The atomic clocks aboard GPS satellites run approximately 45 microseconds faster per day compared to identical clocks on Earth's surface. But the satellites are also moving at about 14,000 kilometers per hour relative to Earth's surface. This orbital velocity causes special relativistic time dilation, making the satellite clocks run about 7 microseconds slower per day. The net effect is that satellite time runs 38 microseconds faster than Earth time daily. These combined temporal corrections are crucial for maintaining GPS location accuracy within a reliable 10-meter margin. Without these corrections, your GPS would become useless within hours. Position errors would accumulate at roughly 11 kilometers per day. The navigation system that guides everything from your morning commute to transcontinental flights exists only because engineers understand that manipulating space automatically manipulates time. The geometry of spacetime can be visualized as a stretched rubber surface that curves under the weight of massive objects. Earth, with its mass of 6 trillion kilograms, creates a depression that curves space and simultaneously slows time. These aren't separate effects. They're different aspects of the same geometric distortion in the fabric of spacetime itself. You can measure this temporal distortion with atomic clocks. If you synchronize 2 identical atomic clocks at sea level, then carry one to the top of a 3-kilometer mountain, after just one day, you'll find a measurable difference between them. Time at the mountain peak flows approximately 30 nanoseconds faster per day due to slightly weaker gravity at that altitude. These extraordinarily precise measurements confirm that gravity literally distorts the flow of time in measurable, real quantities. The effect is tiny at human scales, but it's always present. Every time you climb a flight of stairs, you enter a region where time flows infinitesimally faster. Every time you descend to a basement, time slows by an amount so small that only atomic clocks can detect it, but the effect is absolutely real. Black holes represent the extreme case where space-time distortion becomes so intense that it creates an absolute event horizon. At the event horizon of a black hole containing 10 times the sun's mass, time literally stops from the perspective of an outside observer. If you could somehow hover just outside that boundary and watch someone fall in, you would see them slow down, freeze, and remain frozen at the horizon forever. But here's the mind-bending part. The falling observer would experience time normally. From their perspective, they would cross the event horizon in a finite time and continue falling toward the singularity. Meanwhile, they would see the entire external universe accelerating, aging, and evolving all the way to the end of time in what feels like moments to them. To observers experiencing the same event, measuring completely different temporal realities. This inseparable union of space and time means that any spatial shortcut necessarily involves a corresponding temporal shortcut. Inevitably, when you traverse a wormhole that shortens spatial distance, you inevitably traverse temporal distances that aren't obvious at first analysis, but become catastrophic upon closer examination. Consider a wormhole with mouths separated by 10 light years. Crossing instantaneously means arriving before light could have completed the conventional journey through normal space. But from light's perspective, a journey of 10 light years through normal space necessarily corresponds to 10 years of elapsed time. Light always travels at the same speed, so distance and time are locked together in a fixed relationship. The shortcut through the wormhole allows you to arrive in seconds, effectively traveling 10 years into the future relative to the conventional light speed path. This temporal discrepancy isn't merely semantic or philosophical. It represents a real violation of the causal structure that keeps physics coherent and predictable. Think about what this means for causality. If you can travel 10 light years instantaneously, you've essentially moved 10 years into the future relative to information traveling at light speed. You could, in principle, send a signal back to your starting point through normal space, and that signal would arrive 10 years before you originally left. This creates the potential for closed time-like curves, paths through space-time that loop back to their own past. You could receive a message that you yourself will send in the future. You could learn information that you haven't discovered yet. You could potentially prevent yourself from making the journey that allowed you to send the information in the first place. But the situation becomes even more disturbing when you realize that Einstein's relativity provides multiple ways to convert future-directed time travel into past-directed time travel. The very structure of space-time, combined with the possibility of moving between reference frames at high velocities, creates scenarios where cause and effect become hopelessly tangled. The wormhole has transformed from an innocent spatial shortcut into something far more sinister. What seemed like a simple engineering problem, how to travel quickly between distant points, has become a fundamental assault on the logical structure of reality itself. The temporal shortcuts created by spatial manipulation don't just bend the rules of physics, they break them completely. And here begins the true catastrophe. Because relativistic physics guarantees that traveling to the future can be converted into traveling to the past through relativistic maneuvers that are perfectly legal according to Einstein's equations. The wormhole doesn't just allow faster-than-light travel, it inevitably creates the possibility of closed causal loops that would render the entire universe logically inconsistent. And here begins the true catastrophe. Because relativistic physics guarantees that traveling to the future can be converted into traveling to the past. The mechanism for this conversion is both elegant and terrifying in its simplicity. Traveling to the future through rapid motion is perfectly permitted and violates no known physical laws currently. In fact, we do this all the time, though usually in amounts too small to notice. Every time you drive to work, you age slightly less than someone who stays home, though the difference is measured in nanoseconds. But combining a wormhole with relativistic motion creates the possibility of returning to your own past through a specific and inevitable maneuver. The mathematics of this process were worked out in rigorous detail, and what emerges is perhaps the most elegant paradox in all of physics. Imagine a wormhole with mouth A remaining stationary on Earth, while mouth B is transported to Proxima Centauri at 80% of light speed. This isn't an arbitrary choice of velocity. It's fast enough to create significant time dilation effects while remaining well below light speed, perfectly within the bounds of known physics. The journey to Proxima Centauri, 4.2 light-years away, would take 5.3 years according to stationary clocks on Earth, observing the transport. During those 5.3 years, Earth continues its normal progression through time. Clocks tick at their usual rate. People age normally. The calendar advances day by day in the familiar rhythm of terrestrial time. But the clock traveling with mouth B of the wormhole would experience only 3.2 years due to intense relativistic time dilation. This isn't theory. It's the same time dilation effect that GPS satellites experience, just amplified by the much higher velocity. The mouth of the wormhole, traveling at 80% of light speed, literally ages more slowly than its stationary counterpart on Earth. When Mouth B arrives at its destination, there exists a 2.1-year difference between time on Earth and time at the transported wormhole mouth. This temporal offset is now locked into the wormhole's structure. The two mouths are no longer synchronized in time. They exist at different moments in the universal timeline, connected by a bridge that spans not just space, but time itself. Here's where the time machine reveals itself. A person on Earth in the year 2030 could cross the wormhole from Mouth A to Mouth B and emerge near Proxima Centauri in the year 2027, 9 according to the local calendar at that location. They would have traveled 1 year into the past, relative to Earth's timeline, simply by walking through what appeared to be a spatial shortcut. Now, if this traveler wanted to return to Earth through normal space at any subluminal velocity, they would arrive at Earth sometime around 2032 or later. The 4.2 light-year return journey would take at least 4.2 years even at light speed, which is impossible to achieve for massive objects anyway. More realistically, traveling at achievable velocities, the return journey might take decades or centuries. But here's the devastating twist. The traveler could instead cross back through the wormhole from Mouth B to Mouth A, returning instantaneously to Earth in the year 2027.9 of the terrestrial calendar, the same year they experienced when they emerged at Proxima Centauri. They would have departed in 2030 and returned in 2027, arriving 2.1 years before their own original departure. The traveler would have created a closed time-like curve. They could potentially encounter their younger self, still preparing for the journey that already happened from the traveler's perspective. They could share information about the future, warn themselves about mistakes, or even try to prevent the original journey from taking place. This sequence requires no faster-than-light velocities or obvious violations of relativity. It emerges naturally from combining Einstein's special relativity with the exotic geometry of wormhole spacetime. Every step in the process obeys the known laws of physics, yet the result is a blatant violation of causality that would render the universe logically inconsistent. Physicist Kip Thorne and his colleagues demonstrated mathematically in 1988 that this scenario is an inevitable consequence of traversable wormholes. Their calculations weren't speculative science fiction. They were rigorous solutions to Einstein's field equations, published in peer-reviewed journals, showing that any stable wormhole automatically becomes a time machine given sufficient time and relative motion between its mouths. The temporal window created corresponds exactly to the time difference accumulated during the relativistic transport of one wormhole mouth. If you transport a mouth for longer, or at higher velocity, you create a larger temporal offset. The wormhole becomes a more powerful time machine. There's no way to prevent this effect while maintaining the wormhole's traversability. With a wormhole established, any civilization could use this relativistic trick to send messages or objects to their own past arbitrarily. The implications are staggering. Imagine receiving detailed plans for advanced technology decades before you invented it. Imagine knowing the outcome of experiments before you performed them. Imagine having access to your future discoveries before you made them. A civilization could send blueprints for advanced technology to their own past, enabling accelerated development that seems completely paradoxical. An engineer in 2030 might receive in 2027 the detailed plans for an advanced engine that he himself will design and send back in the future. But where did those plans originally come from? The engine wasn't invented at any specific moment in time. It exists in a closed temporal loop without any identifiable point of creation. The information appears to exist without origin, violating the fundamental principle that every effect must have a temporally prior cause. The knowledge comes from nowhere and everywhere simultaneously, creating something from nothing in direct violation of logical causality. Worse still, a time traveler could return and prevent their own original departure, creating the famous grandfather paradox in its pure and direct form. If they prevent their own departure, then they never travel back in time to prevent it. So the departure occurs, so they do travel back and prevent it again. The logical loop has no consistent solution. If the traveler prevents their own journey, then they never return to the past to prevent it. So the journey happens, so they do return and prevent it again, cyclically and endlessly. This creates an infinite regress of logical contradiction. The universe would be forced into a state where contradictory events must simultaneously be true and false. This logical loop has no consistent solution in either classical or quantum physics, as we currently understand these well-established theories. Classical physics assumes deterministic evolution. Given the state of a system at any moment, the future is completely determined. But closed time-like curves make the future dependent on events that haven't happened yet, breaking determinism completely. Quantum mechanics might seem to offer an escape through its inherent uncertainty, but even quantum evolution requires consistent boundary conditions. The mathematics becomes undefined when past and future become entangled in causal loops. The equations that govern quantum mechanics assume a clear temporal ordering of cause and effect. Recognizing this fundamental threat to physics, Stephen Hawking proposed in 1992 his chronology protection conjecture, suggesting that the laws of physics somehow prevent the formation of time machines. Hawking argued that quantum fluctuations in the vacuum near a wormhole's horizon would grow infinitely large, destroying the structure before it could be activated for time travel. The mechanism Hawking envisioned involves the same quantum vacuum that creates the Casimir effect. As a wormhole approaches the moment when it could enable time travel, quantum fluctuations in the space-time geometry would become amplified. These fluctuations would grow without bound, creating infinite energy densities that would collapse the wormhole into a black hole before the first particle could complete a journey to the past. Semi-classical calculations do show that energy density near regions of potential time travel tends toward infinity as the moment of activation approaches. The mathematics suggests that the universe has a built-in defense mechanism against temporal paradoxes, automatically destroying any structure that could enable causality violation. But these calculations depend on approximations, and no complete theory of quantum gravity exists to definitively confirm this chronology protection. The semi-classical approach treats gravity as classical while keeping matter quantum mechanical. A complete theory might reveal loopholes in Hawking's conjecture, or it might confirm that time machines are absolutely forbidden by deeper principles we haven't yet discovered. Some physicists argue that quantum mechanics with a many-worlds interpretation could resolve paradoxes by allowing branching timelines. In this view, a returning time traveler would create a new parallel timeline where they prevent their departure while the original timeline remains intact and preserved. The traveler wouldn't be changing their own past, but creating an alternate reality. However, this resolution requires the infinite multiplication of complete universes, each containing trillions of galaxies. Every time someone makes a temporal journey, the entire cosmos would split into multiple branches. The violation of scientific parsimony is staggering. Infinite worlds created to resolve a single logical contradiction. This many-world solution also fails to address the fundamental problem. If every possible timeline exists, then timelines containing unresolvable paradoxes must also exist. The many-worlds interpretation doesn't eliminate paradoxes. It multiplies them infinitely across an ever-expanding tree of parallel realities. Whatever the resolution might be, the mere existence of a wormhole forces physics to choose between temporal paradoxes or infinite multiplication of realities. Both options represent complete breakdowns of the logical structure that makes science possible. Either the universe contains contradictions, or it contains infinite duplications, or it contains built-in mechanisms that violate the very equations that permit wormholes in the first place. The elegant spatial shortcut has become a logical nightmare that threatens the foundations of rational thought itself. The wormhole doesn't just bend space-time, it breaks logic, causality, and the possibility of consistent physical law. What began as a simple desire to travel quickly between distant points has evolved into an assault on the basic principles that make the universe comprehensible. Whatever the resolution, the mere existence of a wormhole forces physics to choose between temporal paradoxes or the infinite multiplication of realities. But causal violations are just the first layer of destruction that wormholes would inflict upon the solidly established foundations of modern physics. Even if we could somehow resolve the temporal paradoxes, perhaps through Hawking's chronology protection or some undiscovered principle that prevents closed time-like curves, wormholes would still demolish another pillar of physical law that's even more fundamental than causality itself. Conservation of energy states that the total energy in an isolated system remains constant, never increasing or decreasing spontaneously. This principle is so basic that we rarely think about how profound it really is. Energy can change forms, kinetic to potential, chemical to thermal, matter to pure energy, but the total amount never changes. It's like a cosmic bank account that only changes through explicit deposits or withdrawals, never generating money from nothing magically by itself. This law is considered more fundamental than gravity itself, more basic than electromagnetism, because it relates to the temporal symmetry of the universe at the deepest possible level. In 1915, mathematician Emmy Noether proved a theorem that connects conservation laws to symmetries in nature. Noether's theorem demonstrates that conservation of energy emerges from the fact that physical laws don't change with time. Think about what this means. If the physics that governs Monday is identical to the physics that governs Tuesday, then energy must be conserved as a rigorous mathematical necessity. If an electron behaves the same way today as it behaved yesterday, if gravity has the same strength tomorrow as it has now, then the total energy of any isolated system cannot change. In a universe with static geometry that remains unchanging through time, conservation of energy is guaranteed automatically by the mathematical structure of the fundamental field equations. The symmetry is built into the fabric of space-time itself. Energy conservation isn't just an empirical observation we've happened to notice. It's a mathematical consequence of temporal symmetry. But a wormhole breaks this temporal symmetry by creating shortcuts that connect different moments in time through topologically non-trivial geometry. The wormhole doesn't just connect distant regions of space, it connects different temporal coordinates in a way that violates the very symmetry that gives rise to energy conservation. Consider a simple but devastating example. Imagine an object falling in Earth's gravitational field through wormhole mouths positioned at different altitudes and strategically placed. Position mouth A of the wormhole at 1,000 meters altitude and mouth B at sea level, directly below and vertically aligned. An object released from mouth A would fall under gravity, gaining kinetic energy. After falling 1,000 meters in Earth's gravitational field, it would be moving at approximately 14 meters per second when it reaches sea level. This acceleration is completely normal. Gravitational potential energy converts to kinetic energy exactly as Newton's laws predict. But here's where the wormhole creates an impossible situation. Just before the object touches the ground, it passes through mouth B of the wormhole and instantly reappears at mouth A, 1,000 meters above sea level. The object retains its velocity of 14 meters per second, but now finds itself at the same altitude where it started, ready to fall again. The object falls again, gaining additional kinetic energy, passes through the wormhole, returning to the top, and the cycle repeats infinitely without any external intervention. Each cycle takes approximately 14 seconds, the time needed to fall 1,000 meters under Earth's gravity. But each cycle adds energy to the system without any source providing that energy. After just 100 cycles, completed in about 1,400 seconds, the object would reach a velocity of 1,400 meters per second purely from falling repeatedly through the same gravitational field. That velocity corresponds to kinetic energy of about 980,000 joules per kilogram of the falling object. For a modest 10-kilogram object, that's nearly 10 million joules of energy created from absolutely nothing. The energy is being created from nothing, because Earth's static gravitational field loses no energy, yet the object gains energy indefinitely without stopping. Earth's gravitational field remains completely unchanged. The planet doesn't lose mass, doesn't slow its rotation, doesn't cool down. Yet the falling object accumulates kinetic energy that had to come from somewhere, but clearly comes from nowhere. The total energy content of the universe has increased, violating conservation of energy in the most direct and measurable way possible. This isn't a subtle effect that requires sophisticated instruments to detect. After just a few minutes of operation, the energy violation would be obvious to anyone with a basic velocity meter. Even worse, the falling object could be replaced with an electrical generator that extracts energy from this perpetual fall, producing unlimited free electricity. A generator weighing just 100 kilograms could produce approximately 500 kilowatts of continuous power indefinitely, without fuel or any external energy source whatsoever. To put that in perspective, 500 kilowatts is enough to power about 50 average American homes continuously. Imagine neighborhoods powered entirely by falling objects that never hit the ground, generating endless electricity from gravitational fields that never weaken. The violation of conservation of energy would become an infinitely exploitable resource. This infinite free energy is impossible because it violates the second law of thermodynamics in addition to energy conservation, doubling the catastrophe. The second law requires that entropy, the measure of disorder in a system, must always increase in any isolated system. But a perpetual generator would maintain constant entropy while extracting useful work indefinitely. Think about what a perpetual motion machine really means. It would allow you to do work forever without paying any thermodynamic cost. You could power cities, move mountains, even accelerate spacecraft to tremendous velocities, all without consuming any resources or generating any waste heat. The universe would become a free energy paradise where scarcity disappears and the laws of thermodynamics become meaningless. Some physicists have argued that the wormhole itself possesses mass and energy that would be drained during the energy extraction process, potentially compensating for the apparent violation. If the wormhole structure itself pays the energetic cost, then global conservation might be preserved even as local conservation fails completely. Calculations do suggest that a wormhole would lose corresponding mass as energy is extracted, causing its throat to shrink and eventually collapse when the extracted energy approaches the wormhole's initial mass energy. This means the wormhole might function as a massive cosmic battery rather than a truly perpetual energy source. Once depleted, it would collapse into a black hole or simply disappear. But even this limited violation represents a complete breakdown of local physics. It requires energy transfer through non-trivial topological connections that don't preserve local conservation of energy at each point in spacetime. Energy could appear anywhere a wormhole mouth exists without any local source or cause. In general relativity with wormholes, energy might be conserved globally across the entire universe, but it ceases to be conserved locally at each point in space and time. This means that physics loses its local predictability. Energy could appear or disappear at any location connected by a wormhole without warning or identifiable cause. Imagine the practical consequences. You're driving your car when suddenly the engine gains energy spontaneously because it happens to be near a wormhole mouth. Your laptop battery begins charging itself because energy is flowing through space-time topology you can't see. Nuclear reactors might spontaneously gain or lose energy in ways that have nothing to do with their fuel or control systems. Local conservation of energy is what makes engineering possible. When you design a bridge, you calculate how much energy the materials can absorb before breaking. When you build a power plant, you know exactly how much energy the fuel contains. When you launch a spacecraft, you can predict precisely how much velocity each kilogram of fuel will provide. Without local conservation, engineering becomes impossible because the energy content of any system becomes unpredictable. Materials might spontaneously gain energy and explode. Spacecraft might randomly accelerate or decelerate due to hidden wormhole connections. Power grids could experience inexplicable surges or failures as energy appears and disappears through topological shortcuts. The violation goes deeper than practical inconvenience. If energy isn't conserved locally, then the mathematical framework that connects symmetries to conservation laws breaks down. Noether's theorem assumes that physical laws have specific symmetries, but wormholes break those symmetries in ways that make the mathematics undefined. Physics would lose the mathematical structure that makes prediction possible. The field equations that govern everything from planetary motion to particle interactions depend on energy being conserved at each point in space-time. If that conservation fails, the equations become inconsistent and unsolvable. Even quantum mechanics requires energy conservation to function. The Schrödinger equation that governs quantum evolution assumes that energy eigenstates have definite values that don't change spontaneously. If energy can appear or disappear through wormhole connections, quantum mechanics loses its predictive power completely. The cascade of failure spreads through every branch of physics. Thermodynamics becomes meaningless when energy isn't conserved. Chemistry becomes unpredictable when molecular bonds can gain or lose energy arbitrarily. Biology becomes impossible when cellular processes can't rely on stable energy relationships. Physics loses local predictability because energy can appear or disappear at any point, connected by a wormhole without warning or identifiable cause. The third catastrophe that wormholes would inflict is the destruction of predictability that allows science to make testable and verifiable predictions consistently. This might seem like a lesser concern compared to causality violations and energy non-conservation, but predictability is actually the foundation that makes science possible in the first place. Without it, we wouldn't have science at all. Just random observations of an incomprehensible universe. Predictability means that knowing the present state of a system with precision allows us to calculate future states through reliable, deterministic, mathematical equations. This principle seems so obvious that we rarely appreciate its profound importance. When you throw a baseball, its trajectory is completely determined by the initial velocity and angle of release, according to Newton's laws of motion. The ball doesn't randomly decide to curve left or accelerate upward. It follows a mathematically precise parabolic path. All of astronomy depends on this predictability to calculate planetary positions decades in advance, with kilometer-level precision that's both reliable and consistently verifiable. When astronomers tell you that Mars will be in opposition on a specific date 3 years from now, they're staking their reputation on the mathematical certainty that gravity follows predictable laws. The New Horizons mission, launched in 2006, reached Pluto in 2015 after traversing precisely 5 billion kilometers because physics is totally predictable. Mission planners calculated the spacecraft's trajectory 9 years in advance accounting for gravitational assists from Jupiter and the complex orbital mechanics of the outer solar system. The probe arrived within minutes of the predicted time after a journey longer than the distance from Earth to Neptune. But in a universe with wormholes, information from the future could influence the past, creating causal loops that render equations mathematically indeterminate and completely unsolvable. The mathematical framework that allows prediction breaks down when future states can retroactively influence the initial conditions that were supposed to determine those very future states. Normally, a physical system described by differential equations has a unique solution determined by initial conditions specified at time zero. You measure the position and velocity of every particle in a system at some initial moment, plug those values into the appropriate equations, and the mathematics tells you exactly what will happen at all future times. This is how we predict eclipses, launch spacecraft, and design every piece of technology. The Schrödinger equation that governs quantum mechanics also has a unique solution given an initial wave function known precisely at a specified starting time. Even in the probabilistic quantum realm, the mathematics is completely deterministic. The wave function evolves according to precise equations, and while individual measurements are random, the statistical patterns are perfectly predictable. But with closed time-like curves, the same wave function must satisfy boundary conditions in both the past and the future simultaneously. This transforms a well-defined problem with a unique solution into an overdetermined problem with either infinite possible solutions or no consistent solution at all. It's like trying to solve an equation with two unknowns but three imposed conditions that might be mutually incompatible and logically contradictory. Physicist David Deutsch proposed in 1991 that quantum mechanics could remain technically consistent in spacetimes with closed temporal curves. Deutsch showed that the quantum density matrix could avoid discontinuities if it allows superposition of alternative histories to coexist quantum mechanically. In his framework, the universe would automatically select the unique quantum state that remains consistent with its own future evolution. But this solution requires that fundamental physics be intrinsically non-deterministic, even for large, classical macroscopic systems that we can observe directly. In Deutsch's quantum consistency model, a particle traversing a temporal loop would have an indeterminate destination not because of our ignorance, but because of fundamental ontological indeterminism in the underlying physical reality. At a practical level, this means we couldn't predict whether a particle would emerge from a wormhole, even if we knew all the initial conditions perfectly. The outcome would be fundamentally random, not just apparently random due to our limited knowledge. Reality itself would roll dice at the quantum level to determine macroscopic outcomes. An identical experiment repeated 1,000 times would produce different results each time without any discernible pattern, because reality would be fundamentally stochastic and random. This would utterly destroy the scientific method, which depends on reproducibility. The cornerstone of science is that identical causes produce identical effects under identical conditions, always and verifiably. Engineering would become impossible because bridges wouldn't have determinate strength, but random strength varying unpredictably between apparently identical constructions. Two bridges built from identical materials using identical designs would have completely different load-bearing capacities. One might support heavy trucks, while another, built to the same specifications, might collapse under the weight of a bicycle. Chemistry would lose all meaning because the same reaction would produce different products each time without any possibility of reliable, testable, experimentally reproducible prediction. Mix hydrogen and oxygen under identical conditions, and you might get water one time, hydrogen peroxide the next, or perhaps some compound that doesn't exist in normal chemistry. Chemical bonds would become fundamentally unreliable. Biology would collapse because DNA wouldn't code for specific proteins, but for random proteins varying each time a cell translates an identical gene. The genetic code that allows life to exist depends on deterministic relationships between DNA sequences and protein structures. If those relationships became random, life would be impossible. Consider what this means for your own existence. The fact that you can think coherent thoughts depends on billions of biochemical processes functioning reproducibly trillions of times throughout your life. Every heartbeat, every breath, every neural signal relies on chemistry and physics behaving predictably. Your cells manufacture the same proteins from the same genes today as they did yesterday. If these processes were intrinsically random, complex life couldn't exist because cells would disintegrate into molecular chaos within minutes. Proteins would fold randomly instead of into their required functional shapes. DNA replication would produce random sequences instead of faithful copies. Metabolism would generate random products instead of the specific molecules needed for cellular function. Neurons fire electrical signals in predictable patterns that allow thought and memory to function consistently across decades of human life. The fact that you remember your childhood, that you can learn new information and retain it, that you can follow a logical argument from premise to conclusion, all of this depends on neural activity being deterministic and reliable. With wormholes destroying predictability, each neural firing would be unpredictable, making coherent thought and stable memory literally impossible. Your brain would become a random number generator, incapable of forming consistent memories or following logical sequences of reasoning. The very thoughts you're having right now require the deterministic operation of billions of neurons working in coordinated patterns. Consciousness and personal identity depend on causal continuity between successive mental states over the time you experience subjectively. Your sense of being the same person who went to sleep last night and woke up this morning relies on the fact that your mental states evolved predictably from past states according to consistent physical laws operating in your brain. If the future could influence the past arbitrarily, there would be no unidirectional temporal flow to support a coherent narrative of continuous, conscious personal experience. Your memories of yesterday might have been retroactively influenced by decisions you haven't made yet. Your current thoughts might be the result of future events that haven't occurred. The linear progression of experience that creates personal continuity would become meaningless. Memories could be implanted retroactively by future events, making the past malleable and unstable instead of fixed and immutable as we experience it. The conversation you had with a friend last week might change based on a decision that friend will make next month. Your recollection of your first day of school might depend on whether your grandchildren decide to study history in college. Nothing in your past would be stable or reliable. The decision you make today could be influenced by the future consequences of that decision through circular causal loops without beginning or end. You might choose to study physics because of a discovery you'll make in the future, but you only make that discovery because you chose to study physics. The decision and its consequences would exist in a closed loop with no identifiable origin in time. This creates infinite regress in human choice and agency. Every decision becomes dependent on its own future consequences, which are dependent on other decisions, which are dependent on their consequences, in an endless chain of circular causality. Free will becomes meaningless when your choices are determined by their own outcomes. Consider how this would affect something as simple as planning your day. You might decide to take an umbrella because it will rain, but it only rains because your umbrella somehow influences weather patterns through a complex causal loop involving future events. The decision to carry the umbrella and the rain that justifies it become locked in temporal circularity. Even language and communication would break down. The meaning of words would become unstable if their significance could be retroactively influenced by future conversations. The sentence you're reading now might mean something different tomorrow based on how this conversation influences your future understanding of these concepts. Science itself would become impossible because experimental results could be influenced by future experiments. A measurement made today might be determined by whether someone decides to repeat that experiment next year. The foundations of empirical knowledge would dissolve into temporal loops where cause and effect become indistinguishable. The universe would lose its narrative temporal structure, leaving only a timeless tangle of events without clear, definable, consistent, reliably identifiable causal ordering. The violations we've described aren't mere technical inconveniences, but represent the complete collapse of the conceptual framework of established modern physics. To understand the full magnitude of this catastrophe, we need to step back and appreciate what physics actually is at its most fundamental level. Physics works by building mathematical models where the present state uniquely determines future evolution through well-defined differential equations, always. This is like a system of linear equations that has a unique solution only when the number of equations equals the number of unknown variables, perfectly balanced. Too few equations and you have multiple possible solutions. Too many equations and you typically have no solution at all. Physics depends on this mathematical balance, enough constraints to determine a unique future, but not so many that the system becomes overdetermined and inconsistent. This mathematical framework allowed humanity to progress from medieval geocentric astronomy to solar system exploration in just 400 years. Think about that transformation. In 1500, most people believed Earth sat motionless at the center of the universe. By 1900, we were calculating planetary orbits with extraordinary precision and beginning to understand the true scale of the cosmos. Newton's laws, published in 1687, enabled calculations of planetary trajectories with accuracy that remained unbeaten for 250 consecutive years. Those same equations that described falling apples also predicted the return of Halley's Comet decades in advance. They guided the discovery of Neptune based purely on mathematical analysis of Uranus's orbital perturbations. The power of deterministic prediction became humanity's greatest intellectual achievement. Maxwell's equations, unified in 1865, predicted electromagnetic waves 22 years before Hertz confirmed them experimentally in 1887. Maxwell didn't set out to predict radio waves. He was trying to understand the relationship between electricity and magnetism. But his mathematical analysis revealed that oscillating electric and magnetic fields must propagate through space at exactly the speed of light, leading him to realize that light itself is an electromagnetic wave. Einstein's relativity in 1915 predicted the bending of light by gravity, which Eddington confirmed precisely during the total solar eclipse of 1919. Einstein's equations suggested that massive objects curve spacetime and that light follows the shortest path through that curved geometry. When Eddington measured starlight bending around the sun during the eclipse, the deflection matched Einstein's prediction to extraordinary accuracy. Quantum mechanics, developed between 1925 and 1927, predicts atomic spectra with precision extending to 15 significant digits, verified experimentally and reproducibly. The energy levels of electrons in atoms can be calculated so precisely that theoretical predictions match experimental measurements to parts per trillion. This represents perhaps the most accurate theoretical framework ever developed by human science. The standard model of particle physics predicts the electron's anomalous magnetic moment with precision of 13 decimal places, an extraordinary accuracy that remains unmatched in any other field. This means theoretical calculations match experimental measurements to 1 part in 10 trillion. To put this precision in perspective, it would be like measuring the distance from New York to Los Angeles and being accurate to within the width of a human hair. This absurd precision, 1 part in 10 trillion, demonstrates that physics is the most thoroughly tested and confirmed theory ever created by humans throughout history. No other field of knowledge approaches this level of predictive accuracy. Economics, psychology, sociology, even chemistry and biology operate with much larger margins of error. Physics stands alone in its ability to make predictions of breathtaking precision, but this entire structure depends on linear causality where the past influences the future, but the future never influences the past, asymmetrically and always unidirectionally. Remove this temporal asymmetry, and the mathematical foundations crumble completely. The equations that govern everything from atomic behavior to galactic motion assume a clear distinction between cause and effect, with causes always preceding their effects. With wormholes enabling bidirectional influence between different temporal moments, equations lose the determinism that makes predictions mathematically solvable and clearly defined. The mathematical machinery of physics requires boundary conditions at the beginning of time evolution. But if the future can influence the past, then future states become additional boundary conditions that must be satisfied simultaneously with initial conditions. This isn't about reduced precision, but fundamental impossibility of making any verifiable, testable, reproducible, experimentally reliable predictions. It's not that our calculations become less accurate. It's that the concept of calculation itself breaks down. We can't solve equations that are simultaneously overdetermined and underdetermined, where the answer depends on its own consequences. It's like trying to predict the outcome of a chess game, where future moves can retroactively alter past moves that have already been executed. The rules cease to exist meaningfully because rules require temporal consistency that wormholes destroy fundamentally through their inherent topological geometric construction. A chess game assumes that once a move is made, it remains fixed in the historical record of the game. Some physicists have speculated that nature might choose among multiple possible solutions through Novikov's self-consistency principle, proposed in 1980. This principle requires that only self-consistent events occur, eliminating paradoxes through natural selection of logically consistent temporal histories. In this view, the universe would automatically select the unique history that doesn't contain contradictions. But this transforms physics from a predictive science into a merely descriptive science that catalogs what happens without explaining why it happened necessarily. It's like pre-Darwinian biology that classified species without any unified explanatory theory, connecting observations in a coherent, comprehensible, universally applicable framework. Description without prediction isn't science, it's natural history. Science would lose the explanatory power that distinguishes it from mere empirical cataloging of observed phenomena without deep, unified, systematic underlying comprehension. The goal of physics isn't just to describe what we see, but to understand why things happen as they do. Predictive power emerges from genuine understanding of underlying mechanisms and principles. Besides, Novikov's principle doesn't specify any physical mechanism that enforces self-consistency, leaving the fundamental question completely unanswered and unverifiable. It's like declaring that only consistent events occur without explaining what force or law prevents inconsistent events from manifesting physically and concretely. The principle becomes a statement of faith rather than a scientific hypothesis. Without a mechanism, the principle becomes a teleological declaration where the universe somehow knows which configurations are consistent and chooses only those magically and mysteriously. This invokes a kind of cosmic intelligence that can foresee all possible futures, evaluate them for logical consistency, and select only the consistent ones. But what gives the universe this remarkable foresight and decision-making ability? Physics has historically rejected teleological explanations where ends determine means because this inverts causality in ways that are logically problematic and philosophically unacceptable. Teleology suggests that future goals somehow reach backward in time to shape present events. It's the difference between saying the rock falls because gravity pulls it down and the rock falls because it wants to reach the ground. Gravitation doesn't work because stones want to fall, but because mass curves space-time, forcing trajectories through mathematically determined local geometry. Einstein's insight was that gravity isn't a force pulling objects together, but a geometric property of space-time that determines how objects move. This removed teleology from gravitational physics completely. Introducing teleology to save wormholes from paradoxes would represent a 500-year regression, abandoning conceptual progress achieved since the Renaissance scientific revolution. It would return us to Aristotelian physics, where objects move toward their natural places because they possessed inherent purposes. Modern science progressed by rejecting such explanations in favor of mathematical laws. The final alternative would be to accept that wormholes simply cannot exist, not due to technical impossibility, but due to fundamental, logical impossibility. This wouldn't be a limitation of engineering or available energy sources, but a deep structural feature of reality itself that prohibits certain geometric configurations from existing. Just as square circles don't exist, not due to material limitations, but due to inherent conceptual contradiction in their basic geometric definition. You can't draw a square circle, not because you lack the right drawing tools, but because the concept itself is logically contradictory. Four-sided figures with equal angles and sides cannot simultaneously be shapes where all points are equidistant from a center. Perhaps space-time possesses mathematical structure that intrinsically prohibits non-trivial topologies that would allow wormhole-type connections through fundamentally permitted geometry. This prohibition might be as fundamental as the impossibility of exceeding light speed, not a technological limitation, but a structural restriction of underlying physical reality. Such a prohibition would be as fundamental as the impossibility of exceeding the speed of light. Not a technological limitation, but a structural restriction of underlying physical reality. The impossibility of wormholes reveals something profound about the nature of reality that goes far beyond mere technical limitations of advanced future engineering. This isn't a question of whether some incredibly advanced civilization could eventually develop the technology to construct wormholes by overcoming current material or energy constraints. The issue runs much deeper than engineering challenges. It's not that an advanced civilization can't build a wormhole due to lack of energy or the exotic materials that would be technically challenging to produce today. Even if we imagine a civilization that has mastered energy extraction from black holes, that can manipulate matter at the quantum level, that has solved every engineering problem we can conceive, even such a civilization would face an insurmountable barrier that has nothing to do with technology. The barrier is that a universe which permits wormholes cannot maintain the logically consistent structure necessary for physics to exist meaningfully in any coherent form. This is a fundamentally different kind of impossibility than running out of fuel or lacking the right materials. It's an impossibility rooted in logic itself. Consider the logical impossibility of building a machine that computes the answer to the halting problem mathematically proven impossible by Alan Turing in 1936. Turing showed that no algorithm can determine, for an arbitrary program and input, whether that program will eventually halt or run forever. This isn't because we lack sufficient computing power. It's because the problem contains an inherent logical contradiction that no amount of computational resources can overcome. Turing's halting problem demonstrated that certain problems are impossible, not due to complexity, but due to deep, inherent structural logical contradiction. The impossibility doesn't arise from practical limitations, but from the mathematical structure of computation itself. No matter how powerful your computer becomes, no matter how clever your algorithms, the halting problem remains fundamentally unsolvable. Similarly, wormholes may be impossible, not due to practical difficulty, but due to logical inconsistency with the causal structure that keeps physics functionally coherent. The prohibition wouldn't emerge from insufficient energy or missing materials, but from the mathematical structure of space-time itself. Just as you can't solve the halting problem with a bigger computer, you can't build a wormhole with more advanced technology. This perspective transforms the question from how do we build a wormhole to why does the universe prohibit wormholes as fundamentally as it prohibits explicit logical contradictions. The focus shifts from engineering challenges to understanding the deep logical principles that govern what kinds of structures can exist in a consistent reality. Stephen Hawking speculated that his chronology protection conjecture might represent a fundamental law of complete physics that we haven't yet discovered, including quantum gravity. Just as the second law of thermodynamics prohibits perpetual motion machines through mechanisms we now understand, a new law might prohibit time machines through mechanisms we haven't yet identified completely. Evidence for such a law comes from a striking observational fact. Despite general relativity mathematically permitting wormholes, none has ever been observed naturally in the observable universe. This absence is particularly notable given the vast scales and extreme conditions available in cosmic environments. Our universe is 13.8 billion years old and contains approximately 400 billion trillion stars distributed across 2 trillion galaxies. That represents an almost incomprehensible number of opportunities for wormhole formation. If wormholes could arise naturally under any conceivable astrophysical conditions, we should statistically observe at least some among the trillions of extreme objects currently catalogued by astronomers. Supermassive black holes at galactic centers create conditions where space-time geometry is distorted to the maximum extent permitted by known physics. These objects contain millions to billions of times the Sun's mass compressed into regions smaller than our solar system. The gravitational fields near these monsters approach the theoretical limits of what general relativity can describe. Yet no observational evidence suggests the presence of wormholes even in regions of extreme gravity like the accretion disks of active supermassive black holes. We've observed matter spiraling into black holes at nearly light speed, generating temperatures of billions of degrees and magnetic fields trillions of times stronger than Earth's. If wormholes could form anywhere, it should be in these cosmic laboratories of extreme physics. Black hole collisions detected by LIGO since 2015 show gravitational waves perfectly consistent with standard Schwarzschild geometry without any exotic, non-trivial topology. When two black holes merge, they create the most violent events in the universe since the Big Bang, warping space-time so severely that the distortions propagate across billions of light years. Yet the gravitational wave signatures match theoretical predictions for ordinary black holes exactly. If wormholes represented stable, permitted geometries, at least some black holes should exhibit signatures of non-trivial topology in the gravitational waves they emit. The absence of such signatures after dozens of detected black hole mergers suggests that, even under the most extreme conditions, space-time maintains relatively simple topological structure. The absence of evidence after billions of years of cosmic evolution strongly suggests that nature possesses some unknown mechanism that actively prevents wormhole formation. This isn't just an absence of favorable conditions. It appears to be an active prohibition built into the fundamental laws governing space-time geometry. This implies that physical laws aren't merely descriptive, cataloging what happens to occur, but prescriptive, actively preventing certain logically problematic configurations from existing. The laws don't just describe the patterns we observe, they enforce constraints that maintain the logical consistency of the universe itself. The universe seems to protect its own logical consistency through restrictions embedded in the mathematical structure of the fundamental field equations that govern geometry. Like a computer operating system that prevents programs from violating rules that would cause the entire system to crash irreparably, space-time appears to have built-in safeguards against logical inconsistency. This analogy suggests that physical reality possesses integrity rules that maintain logical consistency even when approximate theories might mathematically permit inconsistent configurations. Just as database software prevents users from entering data that would violate referential integrity, the universe might prevent the formation of structures that would violate causal integrity. A complete theory of quantum gravity might reveal that wormholes are prohibited at a fundamental level, just as electrons cannot occupy identical quantum states simultaneously. The Pauli exclusion principle isn't a practical limitation. It's a fundamental feature of quantum mechanics that prevents certain configurations from existing, regardless of how much energy you apply. The Pauli exclusion principle prohibits identical fermions from sharing the same quantum state, a foundation that explains the stability of ordinary atomic and molecular matter. Without this principle, all electrons in an atom would collapse into the lowest orbital, making matter about 100 trillion times denser and rendering atoms, molecules, chemistry, and biology completely impossible. Analogously, an unknown causal exclusion principle might prohibit space-time configurations that would enable logically impossible temporal causal loops. Such a principle would be as fundamental to space-time geometry as the Pauli principle is to quantum mechanics, not an arbitrary restriction, but a necessary feature that makes consistent physics possible. The discovery of such a principle would be as revolutionary as the discovery of relativity or quantum mechanics in the 20th century, historically transformative and fundamentally paradigmatic. It would represent a profound understanding that causality isn't merely an empirical observation about how things happen to work, but a logical necessity embedded in the mathematical structure of fundamental physical reality. Just as we cannot have Euclidean geometry, where the angles of a triangle sum to something other than 180 degrees due to inherent axiomatic contradiction, the axioms of Euclidean geometry logically require that triangular angles sum to exactly 180 degrees. Any deviation would create mathematical inconsistency that renders the entire geometric system meaningless. Perhaps we cannot have a physical universe with causal loops because this would contradict fundamental axioms of a final definitive physical theory that we haven't yet formulated completely. The prohibition against closed time-like curves might be as fundamental to physics as the parallel postulate is to Euclidean geometry. Not an arbitrary rule, but a logical requirement for mathematical consistency. The impossibility of wormholes would then reflect not a limitation of human knowledge or engineering capability, but an intrinsic necessary characteristic of any logically consistent universe that could possibly exist. The question of wormholes forces us to reflect on why physical laws have the particular form they do, instead of the infinite alternatives that seem logically conceivable. This might seem like an abstract philosophical question, but it cuts to the heart of one of the deepest mysteries in science. Why is the speed of light exactly 299,792,458 meters per second, and not 50 million or 1 billion in our arbitrarily chosen conventional units? When you think about it, there's nothing obvious about these values. The speed of light could, in principle, be any velocity. The gravitational constant could be stronger or weaker. The charge of an electron could be different. Yet our universe operates with a very specific set of numerical values that seem precisely calibrated for stability and complexity. These fundamental constants appear arbitrary at first glance, but a universe with even slightly different values would be radically different and probably inhospitable to complex life capable of observation. It's as if reality operates according to a recipe where changing any ingredient by even small amounts would ruin the entire dish. Consider the fine structure constant, which determines the strength of electromagnetic forces. Its value is approximately 137.036, a seemingly random number that appears to have been plucked from thin air. This dimensionless number governs how strongly electrons bind to atomic nuclei, determining the size of atoms and the strength of chemical bonds. But if this constant were just 4% larger, carbon couldn't form in stellar cores, completely eliminating the chemical foundation of all known life and making organic biology impossible. The nuclear fusion processes that create heavy elements in stars depend on precise energy levels and reaction rates. A slightly stronger electromagnetic force would prevent the triple alpha process that fuses 3 helium nuclei into carbon, leaving the universe with only hydrogen and helium. Without carbon, there would be no complex organic chemistry, no amino acids, no proteins, no DNA, no hydrocarbons. The universe would be a sterile place of simple gases, incapable of supporting the intricate molecular machinery that makes life possible. If the fine structure constant were 4% smaller, oxygen would be unstable, making water impossible and eliminating the universal solvent necessary for terrestrial biochemistry. Atomic nuclei would bind differently, making oxygen isotopes decay rapidly instead of remaining stable for billions of years. Without stable oxygen, water couldn't exist as a stable compound. Water isn't just important for life as we know it. It may be essential for any conceivable form of complex chemistry. Its unique properties as a solvent, its ability to form hydrogen bonds, its expansion upon freezing, even its transparency to visible light. All these characteristics depend on the precise electromagnetic properties determined by fundamental constants. This extraordinary precision suggests that the values of fundamental constants aren't random, but perhaps uniquely compatible with a logically coherent, stable, self-consistent universe. The constants appear to be fine-tuned not by design, but by logical necessity. Only certain values permit a universe that can exist stably over cosmic timescales while supporting sufficient complexity for structure and organization to emerge. Think about what this means. If the universe is a vast space of possible physical laws, perhaps only a tiny region of that space corresponds to realities that can maintain logical consistency while supporting complex structures. We exist in that narrow region not because someone designed it that way, but because it's the only region where existence itself is possible. Wormholes would represent the same type of self-inconsistency that nature prohibits, similar to how it prohibits values of constants that would destroy atomic, molecular, and chemical stability. Just as the universe seems to have built-in protection against parameter values that would make matter unstable, it might have built-in protection against geometric configurations that would make causality unstable. The anthropic argument suggests that only universes with laws permitting observers can be observed, creating an obvious but profound philosophical selection bias. This reasoning is sometimes called the weak anthropic principle. We observe a life-compatible universe because we couldn't observe any other kind. If wormholes made physics so inconsistent that intelligent life couldn't emerge, we naturally wouldn't observe wormholes because we wouldn't exist to observe anything at all. But this raises a deep and troubling question. Is the universe consistent because inconsistency is logically impossible, or because only consistent universes generate observers capable of noticing that consistency? Are we discovering necessary truths about reality, or are we simply observing the one reality out of many where observers happen to be possible? These questions touch the boundary between physics and metaphysics, where empirical science encounters the limits of what can be experimentally tested and directly observed. We find ourselves in the strange position of trying to use science to understand the foundations of science itself. Can we ever step outside our own universe to evaluate whether its laws are necessary or contingent? We cannot test other universes with different physical laws to verify whether inconsistencies truly prevent existence or merely prevent observers from arising within them. This represents a fundamental limitation of the scientific method. We have access to only one universe, our own, making it impossible to conduct controlled experiments on the effects of different physical laws. The situation is like trying to understand the nature of consciousness by examining only your own mind. You can't step outside your consciousness to observe it objectively, just as you can't step outside your universe to observe it from an external perspective. Yet somehow, you must use consciousness to understand consciousness, just as you must use physics to understand physics. Some physicists theorize a multiverse where all possible combinations of physical laws exist in separate universes, forming an infinite ensemble of diverse parallel realities. In this view, our universe would be one among infinitely many, where specific laws permit sufficient complexity for intelligent life to evolve naturally over billions of years. This multiverse hypothesis offers a potential resolution to the fine-tuning puzzle. If all possible universes exist, then the apparent fine-tuning of our universe becomes a selection effect. We observe fine-tuned parameters not because they're special, but because only fine-tuned universes contain observers. The vast majority of universes in the ensemble would be sterile, but we couldn't be in those to notice their sterility. String theory suggests the existence of approximately 10,500 distinct vacuum states, each corresponding to a universe with slightly different particular physical laws. This number, 10 to the 500th power, is so incomprehensibly vast that it defies human intuition. To put it in perspective, there are only about 10 to 80 atoms in the observable universe. The string theory landscape contains more possible universes than there are atoms in our cosmos, raised to the power of atoms in our cosmos, and then some. This vastness suggests that any physically permitted combination of laws probably exists somewhere in the hypothetical, speculatively theorized, mathematical multiverse. Every possible variation on the theme of physics would be realized in some bubble universe within the infinite ensemble. Universes where gravity is stronger or weaker, where the speed of light is different, where entirely new forces exist that we can't even imagine. In such a multiverse, universes with wormholes might exist, but simply contain no observers because inconsistent physics prevents the emergence of organized, self-sustaining, persistent complexity. The breakdown of causality, energy conservation, and predictability would prevent the formation of stable structures complex enough to support biological evolution. Such universes might contain only chaos, random fluctuations without pattern or purpose. Alternatively, perhaps inconsistent physics doesn't even allow a universe to exist, generating immediate collapse into nothingness before any material structures can form temporally. The logical contradictions might be so severe that they prevent space-time itself from maintaining coherent existence. Such universes would blink out of existence the moment they began, if they could begin at all. Imagine a universe where effects could precede causes. How could such a reality even get started? If events at time t depend on events at time t plus 1, which depend on events at time t plus 2, and so on infinitely, there would be no way to specify initial conditions. The universe would face an infinite regress problem that might prevent it from existing at all. These speculations remain unprovable because we lack empirical access to other universes and have no confirmed final theory of complete multiversal quantum gravity. We're limited to theoretical reasoning about scenarios that may be forever beyond experimental verification. The multiverse, if it exists, appears to be permanently isolated from direct observation. We might never know whether other universes exist, let alone what laws govern them, but they reveal that the apparently technical question about wormholes connects profoundly with fundamental questions about the nature of existence, reality, and possibility itself. Why does anything exist instead of nothing? And why does that something possess the specific mathematical structure that permits description through elegant, symmetric, comprehensible equations? This is perhaps the deepest question in all of philosophy and science. Gottfried Leibniz called it the fundamental question of metaphysics. Why is there something rather than nothing? Modern physics hasn't answered this question. It has only made it more precise and more puzzling. Physicist Eugene Wigner in 1960 described the unreasonable effectiveness of mathematics in the natural sciences as a profound mystery still without satisfactory, consensual, definitive explanation. Mathematical concepts developed for pure abstract reasoning turn out to describe physical reality with extraordinary precision. Why should the universe operate according to mathematical principles that human minds can discover and understand? Why is the universe mathematically intelligible to human minds that evolved to survive on African savannas, not to comprehend relativistic quantum cosmology? Our brains developed through millions of years of natural selection to track moving objects, recognize faces, avoid predators, find food, and navigate social relationships. There was no evolutionary pressure to understand the curvature of spacetime or the behavior of subatomic particles, yet somehow these same neural circuits, evolved for survival in small hunter-gatherer groups, can understand black holes, quantum mechanics, and the expansion of the universe. We can contemplate the behavior of matter at temperatures of billions of degrees and pressures millions of times greater than Earth's atmosphere. We can reason about events that occurred microseconds after the Big Bang and predict the fate of the cosmos trillions of years in the future. Perhaps the universe is necessarily intelligible because only intelligible universes can exist without collapsing into fundamental logical inconsistency that prevents existence itself. This would suggest that mathematical comprehensibility isn't an accident, but a requirement. Unintelligible universes might be logically impossible, not just practically incomprehensible. This radical idea would suggest that logic precedes physics and that physical laws are particular instances of more fundamental logical restrictions that govern possibility itself. In this view, mathematical truth isn't something humans invented or discovered, but something that defines what kinds of realities can exist. The universe obeys mathematical laws not by choice or chance, but by logical necessity. Wormholes would be prohibited, not by any specific physical law, but by deeper logical impossibility that underlies all possible physical laws in all conceivable universes. They would join the company of square circles, married bachelors, and other logically contradictory concepts that cannot exist in any possible world. This perspective elevates physics beyond empirical science to a quasi-mathematical discipline where we discover necessary truths through rigorous, systematic, pure, deductive reasoning. Rather than just describing what happens to occur in our particular universe, physics would reveal what must occur in any logically possible universe. The laws we discover would be not contingent facts, but necessary truths. And it suggests that our capacity to reason about physics isn't an evolutionary accident, but a reflection of the inherent logical structure that reality must possess to exist meaningfully. We return to our initial verdict with deepened understanding. A single wormhole would completely destroy the consistency of all established, solidly tested modern physics. But now we comprehend the full scope of this destruction. It's not that wormholes would make calculations difficult or reduce precision in our measurements. The catastrophe runs far deeper than computational inconvenience or experimental uncertainty. The devastation would eliminate the very possibility of making verifiable predictions about observable, measurable, physical reality. Without the ability to predict, science becomes impossible. We would lose not just accuracy, but the entire framework that allows us to connect present observations with future expectations. The universe would become fundamentally incomprehensible. Causality would collapse, permitting effects to precede causes through closed temporal loops without any identifiable origin or clearly defined temporal localization. Past and future would become entangled in ways that make the concept of temporal sequence meaningless. Events would exist in circular relationships where each is both cause and effect of every other, creating logical contradictions that have no resolution. Energy conservation would disintegrate, allowing the arbitrary creation and destruction of energy through non-local topological connections that are spatially separated and temporally disconnected. The universe could spontaneously generate infinite energy from nothing, or entire regions could simply lose their energy content without explanation. The fundamental accounting principle that makes physics predictable would break down completely. Predictability would evaporate, transforming physics from a deterministic science into mere empirical cataloging of random events without any discernible, reproducible, systematically verifiable patterns. We would be reduced to recording what happens without any understanding of why it happens or any ability to forecast what might happen next. Science would become indistinguishable from arbitrary record-keeping. These aren't three independent catastrophes, but different aspects of a single, more fundamental collapse of the causal structure that sustains the possibility of doing science rationally. The breakdown of causality, energy conservation, and predictability are interconnected symptoms of the same underlying disease, the destruction of the logical framework that makes rational inquiry possible. Science depends on assuming that reality possesses intelligible order where patterns observed today will remain valid tomorrow under similar, experimentally reproducible conditions. This assumption isn't optional. It's the foundation that makes the scientific method possible. Without temporal consistency, we couldn't distinguish between genuine natural laws and random coincidences. Without this temporal consistency, the scientific method loses its foundation because experiments wouldn't be reproducible and predictions couldn't be tested meaningfully or reliably validated. If the same experimental setup could produce different results for no identifiable reason, then controlled experimentation becomes pointless. We could never determine whether observed effects were due to the variables we're studying or to random fluctuations in the laws of physics themselves. Wormholes therefore represent not just a technically impossible exotic phenomenon, but a type of impossibility that protects the very possibility of scientific rationality existing functionally. They're prohibited for the same reason that logical contradictions are prohibited. Not because they're difficult to create, but because they would destroy the coherence of reality itself. Consider the logical impossibility of a square circle. This isn't a technological limitation, but a conceptual necessity that maintains Euclidean geometry as internally consistent and mathematically rigorous. We can't draw a square circle not because our drawing tools are inadequate, but because the concept itself contains an inherent contradiction. Similarly, wormholes might be prohibited by the logical structure of space-time itself. Perhaps physical laws aren't arbitrary or contingent, but uniquely compatible with a logically consistent universe capable of containing complex, self-sustaining, persistent structures. This would mean that the physics we discover isn't one possible physics among infinitely many alternatives, but the only physics that can support a coherent reality. The laws of nature would be necessary rather than accidental. This uniqueness would imply that the physics we're discovering isn't one among infinite possible physics, but the necessary physics for any self-consistent existing reality. The equations that govern our universe wouldn't be cosmic coincidences, but logical necessities. Just as mathematical theorems are true by logical necessity rather than empirical accident, physical laws might be true by logical necessity rather than historical contingency. The fundamental constants wouldn't then be improbable fine-tuned adjustments, but unique values compatible with the existence of a mathematically intelligible, rationally comprehensible, descriptively accessible universe. The speed of light, the strength of gravity, the charge of the electron. All these quantities might have their specific values not because of cosmic luck, but because those are the only values that permit a logically consistent reality. The question wouldn't be, why do the constants have these values, but why did we think they could have different values when only these permit coherent existence? Our surprise at the apparent fine-tuning of the universe might reflect our failure to understand that alternative values would lead to logical contradictions, not just different physics. Perhaps there's only one way to build a universe that can actually exist. The impossibility of wormholes would then be a specific instance of a general principle. Reality permits only configurations compatible with maintaining its own logical consistency. The universe acts as a self-regulating system that actively prevents the emergence of paradoxes through restrictions embedded in the fundamental equations governing material and energetic behavior. This vision suggests that physics is more profound than mere empirical description, being the discovery of the necessary logical structure that any reality must possess to exist meaningfully. We're not imposing arbitrary order on observed chaos, but discovering pre-existing inherent order that permits observers to exist and discover it reflexively. The comprehensibility of the universe isn't accidental, but necessary. We don't invent physics by imposing arbitrary order over observed chaos, but discover pre-existing inherent order that allows observers to exist, to discover it reflexively. This creates a beautiful circularity. The universe must be comprehensible for observers to evolve who can comprehend it. Incomprehensible universes would be evolutionary dead ends, incapable of producing the complexity needed for intelligence. The journey of understanding why wormholes break physics reveals as much about the structure of reality as about the nature of scientific and philosophical human knowledge itself. It demonstrates that science isn't just a useful tool for manipulating the environment, but a window into the fundamental logical structure that makes existence possible. Our ability to do physics reveals something profound about the nature of reality itself. It shows that science isn't just a collection of facts, but an interconnected system where each law sustains others, creating a robust network resistant to isolated particular local modifications. Pull on any thread in the fabric of physics, and the entire tapestry responds. Remove any fundamental principle, like causality, and cascading failures propagate through the entire unified theoretical structure that has been historically developed with patience and care. Remove any fundamental principle like causality, and cascading collapses propagate through the entire unified theoretical structure that has been established and historically developed with patience. This fragility is also a strength because it means that modern physics is highly constrained by logical necessities, not by arbitrary, convenient, pragmatic, contingent choices. The laws we discover aren't convenient fictions, but necessary truths. This constraint is also a strength because it means modern physics is highly restricted by logical necessities, rather than arbitrary, convenient, pragmatic, contingent choices. The more constrained a system, the smaller the space for alternatives, and the greater our confidence that the solution we found isn't one among many, but the only one compatible with accumulated observations. The more constrained the system, the smaller the space for alternatives, and the greater confidence that the solution found isn't one among many, but the only one compatible with accumulated observations. 3 centuries of experimental testing converging on the Standard Model and general relativity suggests that we're discovering deep truths, not just building convenient provisional models. The convergence of independent lines of evidence toward the same theoretical framework indicates that we're approaching genuine understanding. 3 centuries of experimental testing converging toward the Standard Model and general relativity suggests we're discovering profound truths, not just constructing convenient provisional models. The impossibility of wormholes is therefore a victory of understanding. We've succeeded in identifying why certain configurations don't exist by understanding the logical restrictions that govern possibility itself. The impossibility of wormholes is then a victory of comprehension. We've managed to identify why certain configurations don't exist by understanding the logical restrictions that govern possibility itself. This understanding is more valuable than any hypothetical technology because it reveals the fundamental structure of how reality functions profoundly, consistently, universally, applicably, and intelligibly. This understanding is more valuable than hypothetical technology because it reveals the fundamental structure of how reality works profoundly, consistently, universally applicably, and intelligibly. In the end, the protection that the universe exercises against wormholes protects not just physics, but the possibility of intelligence emerging and understanding the cosmos reflexively and rationally. In the end, the protection the universe exercises against wormholes protects not only physics, but the possibility of intelligence emerging and comprehending the cosmos reflexively and rationally. A consistent universe permits complex life, which permits consciousness, which permits science, which discovers that the universe must be consistent to allow this circular self-referential process. A consistent universe allows complex life, which allows consciousness, which allows science, which discovers that the universe must be consistent to permit this circular, self-referential process. This circularity isn't vicious, but virtuous, revealing that existence, rationality, and physical consistency form a mutually supporting, interdependent, necessary, foundational, ontological triangle. This circularity isn't vicious, but virtuous, revealing that existence, rationality, and physical consistency form a mutually sustaining, interdependent, necessary, foundational ontological triangle. Wormholes remain impossible, but this impossibility is exactly what ensures that we exist to contemplate this impossibility in the extraordinary, consistent tapestry we call reality. Wormholes remain impossible, but this impossibility is exactly what guarantees that we exist to contemplate this impossibility in the extraordinary, consistent tapestry that we call reality. If you're still awake, it's because the content was really good. So take a moment, leave a like, and subscribe to the channel. It helps a lot. And if you want to keep watching, just click on the video that's appearing right now. I'll see you there.